What's up, guys? Welcome back to MVP Learners. Today we're going to go over how to find tangent lines of graphs. So whenever you're doing these tangent line problems, you need two things. You need a point and you need a slope. So let me write that out here. You need a point and you need a slope. So we're given that the tangent line occurs at x equals 1. So we know that the x value of the point is going to be 1. To get the y value, we're just going to plug it in. So it'll be f of 1 equals, and then that'll be 15 minus 2 times 1 squared. I know my camera is covering it, but I think we all know that that's going to come out to 13. And then the slope, that comes from the derivative. So remember, the derivative is the slope at a given point. So what you're going to do is you're going to take the derivative of f of x. So then you go term by term. The derivative of 15, that's just 0 because it's a constant. The derivative of negative 2x squared, that's going to be negative 4x. You multiply the 2 down, multiply it by the negative 2 in front, and that's how I got that. So then now, all we have to do is just plug in to this. So we just plug in 1 for x, so we get f prime of 1 equals negative 4 times 1 equals negative 4. So that's awesome. Now we have everything we need. We have our point and our slope. So now you just need to put it into point slope form. So the formula for that is y minus y1 equals m times x minus x1. y1 and x1 are they come from these values, and then m is just the slope. So we'll do y minus 13 equals negative 4 x minus 1. And you can leave your answer like that. That's perfectly fine. In fact, if you're taking AP Calculus and your test allows you to leave it like that, I would. But let's say you want to get it in y equals mx plus b form, then you would just distribute that negative 4 in. So that'll be negative 4x plus 4. And then you just add the 13 over to the other side, and then you're left with y equals negative 4x plus 17. So there you go. That is your answer. All right, so for this next one, we're going to use the tangent line to approximate values of a function that might not be easy to do without a calculator. So I'm going to draw the logic behind this. So we have this function x cubed. It'll look something like this when it's graphed out. It'll go like this. And we want to estimate what it is at 3.9 cubed using the tangent line at x equals 4. So the logic behind this is we have this point at 4, and there'll be a tangent line. So that basically will be tangent to the curve at 4. And then if we go to 3.9 on this line, which will be like right here, 3.9, as you see, it's going to be, since it's close to where it intersected the curve, it's also going to be very close to where it corresponds to on the graph of x cubed. So if we plug in 3.9 into our tangent line, it's going to be very similar to the value of x cubed at 3.9. But as you can see, the further away you go, like if I get the value up here on the tangent line, it's going to have a much higher error. But if you're pretty close to where the tangent intersects the curve, then you can estimate the value of the function. So now let me get rid of this drawing and we're going to work this problem out. So just like before, first thing we got to do is get the point and slope. So, when you're making these tangent lines, you always need the point and the slope. We know that x equals 4, and then we just got to plug in 4 into x cubed. So that'll be 64. And then we got to get the slope. So the slope, we'll do our derivative real quick over here. So f prime of x will equal 3x squared. We just use our power rule. And then we do f prime of 4 is going to equal 3 times 4 squared. So that is going to equal 3 times 16. It's going to be 48. So great. We have a slope and we have a point. So now we can do point slope form. So what we can do now is we're going to write it out. So we'll do y minus 64 equals 48 times x minus 4. And then we're pretty much done. All we have to do now to approximate this is just plug in the 3.9 for x. So when we do that, we'll get y minus 64 equals 48 times 3.9 minus 4. And we're basically done now. We just add the 64 over to the other side, and we want to get the value of y, which is going to be like the value on the tangent line, what the y value is. So when we do that, we'll have 48 times 3.9 minus 4. And then we're going to add the 64 at the end. And then you could either work this out by hand, but I'm going to use my calculator. So look, I got it right here. If I type this all in, 48 times 3.9 minus 4 plus 64, it's going to come out to 59.2, which is our answer. And then now, as an experiment, like if I type in my calculator 3.9 cubed, the actual value, so 3.9 cubed actually equals 59.319. So that shows that our approximation is very close. The percent error is going to be very low. But as we go further away from that x equals 4 point, we're going to get a much higher error. So I hope this helps with approximations. I know these can be difficult, but I think if you understand the concept behind them, they're pretty easy. But anyways, that's it for me, guys. Make sure to smash that like button down below and subscribe.